In the deepest hours of night, when the world falls quiet enough to hear the turning of the earth, there exists a certain quality to darkness, a presence rather than an absence. Stars pierce the velvet dome above not as mere points of light, but as ancient eyes gazing back at those who dare to look up. It was during such hours that they first noticed it, a faint smudge against the backdrop of infinity, a traveler sliding between familiar constellations with graceful indifference. The astronomers called it Three-Eye Atlas, another designation in humanity's endless catalogue of celestial bodies. But something about this visitor felt different, as if it carried with it a weight beyond its physical mass. The more they watched it drift across their digital screens and telescope lenses, the more it seemed to watch them in return. Its trajectory whispered of distances beyond imagination, yet its presence felt immediate, like a thought made manifest in the void. The data said it was merely ice and rock, cosmic debris passing through our neighborhood. But the data couldn't explain the quiet unease that settled over those who tracked its journey, couldn't capture the feeling that this object had not found us by accident. In those long nights of observation, some began to wonder if the universe had finally sent us a mirror. Observatory domes turned slowly in the cool night air, their mechanical whispers blending with the sound of wind across desert plains, mountain ridges, coastal bluffs, wherever humans had built their windows to the cosmos. Inside, the blue glow of monitors painted shadowed faces with ghostly light, as fingers tapped at keyboards, adjusting parameters, refining focus, seeking clarity. The coffee grew cold in forgotten mugs, as hours stretched into a timeless state of watchfulness. What had begun as routine observation, another night cataloguing the endless dance of celestial bodies, had shifted into something else entirely, a vigil for which there was no protocol. The object that had appeared in their field of view, first dismissed as just another asteroid or long-period comet, refused to behave as such objects should. Its light signature fluctuated in ways that defied conventional models. Its path through our solar system followed laws of motion that seemed to bend at the edges, not enough to violate physics, but enough to suggest physics not fully understood. And strangest of all was the silence it evoked in those who studied it. Conversations that once flowed freely among colleagues now faltered, replaced by long periods of contemplation, as if some unspoken awareness had entered the room alongside the data streaming in from deep space. Outside, beyond the protective domes and climate-controlled rooms, the night sky spread its ancient tapestry across the darkness, Orion's belt gleaming like distant cities, Cassiopeia tracing her eternal throne among rivers of stars, the Milky Way arching overhead like the backbone of some cosmic leviathan. For billions of years, this sky had watched over Earth, its patterns marking the seasons of countless civilizations, its mysteries inspiring both terror and wonder in the beings that evolved beneath it. And now, into this familiar panorama had come something unfamiliar, not dramatically announced by flaring brightness or sudden movement, but quietly, almost hesitantly, as if testing the waters of our awareness. Three-Eye Atlas moved among the known stars, like a thought moving through a dreaming mind, subtle yet somehow more present than the static background against which it traveled. Those who tracked its passage found their gaze drawn again and again to the monitors displaying its position, pulled by an attention that felt both professional and primal, scientific and instinctive. Something about this visitor spoke to older parts of human awareness, regions of consciousness that remembered when every light in the sky was potentially significant, potentially watching, potentially aware. Numbers speak their own language, one of cold precision and hidden poetry. Before the whispers and theories began, there was only silence and then data. Streams of coordinates and measurements, velocities and albedos, all pointing to something extraordinary. An object unbound by our sun, drifting inward from interstellar space. They named it Three-Eye Atlas, a designation as clinical as the computers that helped track it, yet somehow inadequate for what it represented. This was no ordinary comet or asteroid. It carried within its subtle glow the memory of other stars, other worlds, perhaps other beginnings. The calculations confirmed what some had suspected. This visitor had crossed the vast desert between stars, a journey measured not in miles or kilometers, but in light years and epochs. It was familiar in form, not unlike the comets that had danced around our sun for billions of years, yet foreign in its essence, like encountering a word you recognize but can't quite translate. Scientists leaned into their monitors, adjusted their instruments, and listened more closely, as if the quiet passage of this celestial wanderer might contain voices from the stars themselves, frequencies just beyond human hearing, truths hiding in plain sight. The data arrived in packets, digital fragments of information, harvested from telescopes positioned across the globe and in orbit, each contributing its particular perspective to the emerging picture of 3I Atlas. Spectral analyses revealed chemical compositions both expected and surprising: water ice, carbon compounds, mineral signatures that matched what we know of protoplanetary disks and cometary bodies. But there were anomalies too: absorption lines that didn't match known elements, reflectivity patterns that shifted between observations in ways difficult to attribute to tumbling or outgassing. Orbital calculations told an even stranger story. The object's trajectory, when traced backward through space and time, didn't originate from the Oort cloud, that spherical shell of icy bodies surrounding our solar system like a frozen halo. Instead, it pointed to the depths between stars, to the vast emptiness where no sun's gravity dominates, where objects drift for millions of years in cold, dark isolation. This was only the second such interstellar visitor ever confirmed by modern astronomy, a messenger from a realm humanity had never physically explored, carrying information encoded in its very existence about places we had only imagined. In climate-controlled server rooms, supercomputers hummed with the effort of processing the incoming information, transforming raw data into coherent patterns, searching for meaning in the mathematics of motion and light. The scientists who monitored these machines spoke in hushed tones, their conversations filled with technical language that nevertheless failed to fully capture what they were witnessing. Its albedo doesn't match known compositions, one would say, while another replied, the hyperbolic excess velocity suggests origin from a system unlike our own. Technical terms, jargon developed over centuries to describe celestial mechanics with precision, suddenly seemed inadequate, like trying to describe the experience of music using only the terminology of sound waves and air pressure. Something was being lost in translation, some quality of 3I Atlas that transcended the numbers, yet was paradoxically revealed by them. The researchers found themselves reaching for metaphor in their late-night discussions. It's like it's listening to us, one astronomer said, immediately embarrassed by the unscientific nature of the statement. Yet others nodded, understanding exactly what she meant, feeling the same indefinable sense that this object was not merely being observed, but was somehow participating in its own discovery. As news of the interstellar visitor spread through the scientific community, specialists from diverse fields began contributing to the analysis. Astrobiologists considered whether such an object could carry molecular precursors to life, or even dormant microorganisms between star systems. Physicists specializing in dark matter examined whether its trajectory might have been influenced by invisible mass concentrations during its journey. Computer scientists developed new visualization tools to better represent the complex multi-dimensional data sets being generated. Each discipline brought its particular lens to the mystery, revealing different facets, different possibilities. And in this collaborative effort, something remarkable began to happen. The boundaries between fields started to blur, as if 3I Atlas itself were serving as a kind of interdisciplinary catalyst, drawing together strands of human knowledge that had long been separate. Chemists found themselves in deep discussion with astronomers, mathematicians with biologists, each finding unexpected resonances in the other's perspectives. It was as if this visitor without a name, or rather, with only a numerical designation, was teaching humanity something about the artificial nature of the categories we use to divide knowledge, showing us through its enigmatic presence that reality itself doesn't recognize our scholarly boundaries. To truly comprehend what it means for 3I Atlas to have reached us, one must first understand distance as the universe understands it. Between stars lie oceans of emptiness so vast that light itself, the fastest traveler we know, grows weary crossing them. These are deserts not just of space but of time, where a journey might begin around one sun during the age of dinosaurs on Earth and end around another sun during the age of smartphones and climate change. This wanderer had crossed such an incomprehensible expanse carrying within its frozen heart silent memories of its birthplace. Another system, another sun, another history entirely separate from our own. What forces could have cast it into such lonely exile? What cosmic events might have sent it spinning across the endless dark, patient as only inanimate things can be, until chance or something more deliberate brought it into our brief moment of awareness? And what does it mean for humanity, so young and fragile in cosmic terms, to witness such a traveler? Perhaps in its silent passage lies a reminder that even in the vastness of space, paths can cross, worlds can meet, if only for the briefest of moments. The human mind struggles to grasp astronomical distances. We speak of light years, the distance light travels in a year, moving at 186,282 miles per second, but cannot truly comprehend what such measurements mean. The nearest star to our Sun, Proxima Centauri, lies over 4 light-years away, meaning that when we observe it today we see it as it was 4 years ago, its light having departed before the most recent Olympic Games, before countless births and deaths, conversations and silences. And Proxima is our neighbor in cosmic terms, practically next door. Most stars visible to the naked eye are hundreds or thousands of light-years distant, their light having begun its journey to Earth before Shakespeare wrote, before Rome fell, before the first stone was laid at Stonehenge. When we gaze at the Andromeda Galaxy, we see it as it was 2.5 million years ago, when our earliest human ancestors were first developing stone tools in the African savanna. Against this backdrop of almost incomprehensible remoteness, 3I Atlas had journeyed from a star we can't identify, having been ejected from its home system perhaps millions of years ago, traveling in perfect darkness and silence until it encountered the faint gravitational pull of our Sun, a subtle influence that slightly curved its path as it passed through our neighborhood. What would it mean to travel so far for so long with no destination? Human journeys have purpose, direction, intent. We move from one place to another for reasons we can articulate, with expectations of what we'll find upon arrival. But 3I Atlas, and objects like it represent a different kind of motion, one divorced from consciousness or purpose, one that continues regardless of what it encounters or what encounters it, or so we assume. For in the quiet rooms where researchers tracked its passage, another possibility occasionally surfaced in whispered conversations. What if this journey did have purpose? Not purpose as humans conceive it, with goals and intentions, desires and plans, but something more fundamental, a kind of cosmic imperative to connect distant regions of space through physical transit, to cross the void, not just as an object, but as a carrier of information, a physical link between separate worlds. Such thoughts weren't recorded in official reports or published in peer-reviewed journals. They remained in the realm of late-night speculation, philosophical wonderings after too much caffeine and too little sleep. Yet they persisted, returning like a melody that, once heard, continues to play at the edges of awareness. The weight of infinite distance lies not just in physical space, but in the time it represents. When objects travel between stars, they also travel between epochs. If 3I Atlas originated in a star system 100 light-years away and was ejected from its home at a velocity similar to what we observed as it passed through our system, then its journey would have begun approximately 900,000 years ago, long before Homo sapiens walked the Earth. What was happening on our planet when this wanderer began its journey? Early hominids were spreading across Africa and parts of Eurasia, using simple stone tools, harnessing fire, developing the cognitive capacities that would eventually lead to language, art, mathematics, and science. Perhaps they looked up at the night sky with wonder, as we still do, but lacked the knowledge to understand what they were seeing. And as 3I Atlas continued its silent passage through the void, Earth witnessed the rise and fall of countless species, the slow drift of continents, the coming and going of ice ages, the gradual emergence of beings capable of noticing such a visitor when it finally arrived. In this sense, the interstellar object connected not just different regions of space, but different moments in time, a physical bridge between the ancient past and the present, between what Earth was and what it has become. And in its onward journey, it carries something of us, sunlight reflected from its surface, the subtle gravitational influence of our planet temporarily altering its course, perhaps even molecules from our outer atmosphere brushing against it as it passed. It will continue long after our civilization has transformed or ended, a silent witness to our brief moment in cosmic history. The screens of observatories across the planet glowed with incoming data as telescopes trained their electronic eyes on 3i Atlas. At first, the numbers behaved as expected, plotting a hyperbolic trajectory consistent with interstellar objects. But as days stretched into weeks, subtle irregularities began to emerge, whispers in the data stream that caused researchers to double-check their calculations. There were slight deviations in its path, almost imperceptible variations that couldn't be fully explained by gravitational interactions. More curious still were the reflections of sunlight from its surface, sometimes absorbing wavelengths that ice or dust should reflect, sometimes reflecting what should be absorbed. The readings seemed almost alive, shifting gently between observations, as if the object were responding not just to the physical forces acting upon it, but to the very act of being observed. When they looked closer, adjusted their instruments. For greater precision, the data would shift again, like a thought changing under scrutiny. Some scientists dismissed these anomalies as instrumental error, statistical noise in the endless stream of cosmic information. Others, in the privacy of late-night observation rooms, began to feel a strange sensation, as if the sky itself had become aware of their watching, as if this visitor from beyond our solar system were somehow watching back. The anomalies in the data accumulated slowly, each on its own easily attributed to the natural variation inherent in astronomical observation. Earth's atmosphere distorts incoming light, creating the twinkling effect we see with naked eyes and the slight blurring that telescopes must constantly correct for. Instruments themselves have margins of error, electronic noise that can mimic signal under certain conditions. Space is filled with particles, fields, and radiation that can interfere with observations in unpredictable ways. All these factors and more make astronomy a science of patience, of multiple confirmations, of statistical analysis designed to extract truth from inherently imperfect measurements. The researchers studying 3i Atlas understood these limitations intimately. It was their professional reality, the complex interplay of signal and noise through which they navigated daily. And yet, something about this particular set of anomalies felt different. The variations didn't follow expected patterns of instrumental error or atmospheric distortion. They seemed to respond to the intensity of observation itself, becoming more pronounced during periods of focused study, fading during routine monitoring. One young researcher, analyzing late-night observations, noted that the object's spectral signature showed subtle shifts that corresponded almost exactly with changes in the observation parameters, as if 3i Atlas were adjusting its properties in response to how it was being measured. She dismissed the correlation as coincidental, yet found herself unable to generate an alternative explanation that satisfied the mathematical requirements of probability. In the quiet darkness of observation domes, where time is marked by the slow rotation of the Earth and the gradual movement of stars across digital displays, the boundary between objective measurement and subjective experience sometimes blurs. Astronomers who spend their professional lives parsing the subtle distinctions between signal and noise, between discovery and artifact, develop a kind of intuition that operates alongside their analytical training. They learn to sense when data is behaving as it should, when an observation feels right, even before the statistical analysis confirms their impression. This intuitive dimension of science is rarely discussed in formal settings, yet it forms an essential component of how research actually progresses. As the team studying 3i Atlas continued their work, this professional intuition began sending warning signals, subtle alerts that something unusual was occurring, not just in the object being studied, but in the process of studying it. Equipment that had functioned flawlessly for years began experiencing intermittent errors during observation runs focused on the interstellar visitor. Digital storage systems developed corrupt files that, when recovered, contained data patterns, unlike anything previously recorded. Most unsettling were the reports from multiple team members of strange perceptual effects during extended observation sessions, a sense of time dilating, of awareness extending beyond the confines of the observatory, of thoughts that didn't quite feel like their own. These experiences weren't shared widely, mentioned only in hushed conversations between trusted colleagues, yet they accumulated like a secondary data set running, parallel to the official observations, a growing sense that studying 3i Atlas was somehow changing those who studied it. The mathematics of turbulence, that complex interplay of order and chaos, that shapes weather patterns, ocean currents, and the flow of blood through our veins, has a curious property. It generates what appear to be signals in what should be random noise. Eddies and vortices form temporarily stable structures within fluid dynamics, patterns that persist briefly before dissolving back into chaos, only to reform in similar but never identical configurations. Some researchers began to notice comparable phenomena in the data flowing in from 3i Atlas, transient patterns emerging from what should have been random variations in reflectivity and emissions. These weren't sustained enough to qualify as deliberate signals by conventional standards, yet they occurred with a frequency that strained coincidence. It was as if the object's interaction with sunlight, with the interplanetary medium, with the instruments observing it, were generating a kind of informational turbulence, a complex interplay of order and randomness that constantly hovered at the edge of meaning. When they adjusted their analytical algorithms to search specifically for such patterns, the results were both compelling and inconclusive, statistical significances just above what might be expected by chance, correlations that appeared and disappeared depending on how the data was processed. The echo of meaning without clear meaning itself, like overhearing a conversation in a language almost, but not quite familiar, where the cadence and emotion are recognizable, but the specific content remains elusive. Every object in space tells its story through motion. Planets circle in stately ellipses, comets swoop in long predictable arcs, asteroids tumble and drift in patterns shaped by gravity's ancient hand. But the path of 3i Atlas told a story unlike any other, a geometry that seemed to belong to different rules, different origins. Its trajectory contained angles too precise, curves too elegant for something shaped only by the blind forces of nature. It wasn't chaotic as cosmic debris tends to be. It was structured, mathematical, with a symmetry that felt almost deliberate. As researchers mapped its journey backward and forward through time and space, they found themselves tracing shapes that didn't fit neatly into the categories of known celestial mechanics. There was an architecture to its movement, a grammar in its path that hinted at something beyond random chance, somewhere between the hard edges of scientific measurement and the flowing curves of cosmic symmetry. A quiet unease began to grow among those who spent their nights charting this visitor's journey. For in its elegant motion lay a troubling question. What if some patterns in the universe arise not from the laws of physics alone, but from something that might, in another context, be called intention? The orbital mechanics of celestial bodies follow equations first derived by Johannes Kepler in the early 17th century and refined by Isaac Newton's universal law of gravitation. These mathematical descriptions have proven remarkably robust, accurately predicting the movements of planets, moons, asteroids, and comets across the centuries. Even Einstein's later refinements through general relativity, while crucial for certain precise measurements, leave the fundamental Keplerian framework intact for most practical purposes. Within this mathematical structure, objects follow predictable paths determined by their mass, velocity, and the gravitational influences acting upon them. Comets from the outer solar system sweep inward on long elliptical orbits that bring them close to the sun before returning them to the distant cold. Asteroids generally follow more circular paths, their courses occasionally perturbed by close encounters with larger bodies. Interstellar objects like 3i Atlas should trace hyperbolic trajectories through our system, curves that approach from infinity and return to infinity, never to return. And indeed, the broad outline of 3i Atlas's path matched this expected hyperbola. But within this overall shape, deviations appeared, subtle variations in velocity and direction that, when analyzed closely, revealed a level of mathematical regularity that should not exist in natural objects. One researcher, a mathematician who had previously worked on pattern recognition algorithms, for intelligence agencies, before returning to her first love of celestial mechanics, spent weeks analyzing these deviations. What she found disturbed her enough that she hesitated to share it with colleagues. The variations in 3I Atlas's trajectory, when isolated from the primary gravitational influences acting upon it, formed a sequence of adjustments that corresponded with remarkable precision to a specific mathematical series, not the familiar Fibonacci sequence, but something more exotic, a pattern based on transcendental numbers that appeared in certain advanced theoretical physics equations related to higher dimensional geometry. Such a correlation should not exist in nature. Objects in space don't adjust their courses to match abstract mathematical sequences. They respond only to the physical forces acting upon them. Yet the correlation was there, embedded in the data like a signature hidden in the margins of a letter. When she finally shared her findings with select colleagues, their responses ranged from skepticism to fascination to quiet concern. One senior astronomer, after reviewing her analysis in silence, removed his glasses and rubbed his eyes before saying simply, "If you're right, we're not looking at an object. We're looking at an argument." The most unsettling aspect of 3I Atlas's motion wasn't any single deviation or pattern, but the way these anomalies seemed to evolve over time, becoming more complex, more structured, more difficult to dismiss as coincidental as the observation period extended. It was as if the object were gradually revealing layers of order that had been initially concealed, unveiling a deeper architecture beneath its apparently ordinary surface. Researchers trained in the philosophy of science found themselves questioning basic assumptions about causality and natural law. In conventional scientific understanding, patterns in physical systems emerge from fundamental forces acting consistently over time: gravity, electromagnetism, the strong and weak nuclear forces. These forces don't create meaning or purpose. They simply operate according to mathematical rules that are themselves devoid of intention. And yet, in the motion of this interstellar visitor, something that looked remarkably like purpose was emerging, not in any anthropomorphic sense, not as conscious intention, but as a level of order and structure that transcended what blind physical forces should be capable of generating. It was as if they were witnessing not just the result of natural law, but the expression of some deeper principle that shaped how natural law itself operated, a kind of metaphysics written into the very movement of matter through space. Light has always been our most faithful messenger from the cosmos, carrying across unimaginable distances the secrets of distant stars and galaxies. When focused on 3I Atlas, spectrographs separated this light into its component wavelengths, revealing the chemical signatures one would expect from an interstellar object, but with curious exceptions. At certain frequencies, it shimmered with emissions that matched no known natural process, colors that seemed to pulse with a rhythm too regular, too structured to be random fluctuation. These pulses weren't constant, but neither were they chaotic. They formed patterns, sequences that repeated with subtle variations, like a theme in music, slowly evolving with each repetition. Some researchers dismissed these observations as artifacts of their instruments, interference patterns, wishful thinking. Others began the painstaking process of recording these pulses, measuring the intervals between them, searching for mathematical relationships that might reveal their meaning. For light is, after all, the oldest language in the universe, the fundamental medium through which energy and information have traveled since the cosmos was young. And in the strange rhythmic glow of this interstellar visitor, something seemed to be saying something that human ears had never heard, in a language no human mind had yet learned to translate. As they listened with their machines to this silent symphony of light, a disquieting thought began to form. What if these weren't just emissions, but expressions? The electromagnetic spectrum extends far beyond what human eyes can perceive, from radio waves with wavelengths measured in kilometers to gamma rays measured in picometers, a range of over 15 orders of magnitude, of which visible light occupies only a narrow band. Modern astronomy uses this entire spectrum as its palette, employing specialized instruments to detect and analyze radiation across all these wavelengths. When 3I Atlas was observed across this full spectrum, each frequency range revealed different aspects of its nature: infrared showing thermal properties, ultraviolet indicating surface composition, radio waves probing internal structure. But it was in the narrow band of visible light, particularly in the transitions between colors at specific wavelengths, that the most puzzling patterns appeared. These weren't the absorption or emission lines typically used to identify elements and compounds. They were something more complex, rhythmic fluctuations in intensity that occurred at precise intervals, following sequences that mathematicians recognized as related to prime numbers, to the mathematical constant pi, to geometric progressions that appear in certain quantum field equations. One spectroscopist, who had previously worked in cryptography, recognized structures similar to those used in advanced encryption, patterns designed to carry information while appearing random to observers lacking the proper decryption key. "It's as if," she explained to colleagues during a late-night analysis session, "the object is transmitting something in a code designed to be recognizable as a code, but not immediately decipherable." The patterns became more evident when observed over extended periods, revealing themselves not in single observations, but in the relationships between observations taken at different times. It was as if 3i Atlas were communicating not through static signals, but through change itself, through the way its emissions evolved and transformed. This temporal dimension of the phenomenon presented significant challenges to conventional analysis methods, which typically focus on finding consistency rather than meaningful variation. New algorithms had to be developed specifically to track these complex patterns of change, to detect order within what initially appeared to be random fluctuation. As these analytical tools evolved, so too did the patterns they revealed, becoming increasingly structured, increasingly specific, increasingly difficult to attribute to chance or instrumental artifact. The research team found itself drawn deeper into analysis that crossed the boundaries between astronomy, mathematics, information theory, and even linguistics. They weren't just studying an object anymore. They were studying what seemed to be a dynamic system of information exchange, a form of expression that used light itself as its medium. And as they developed greater sensitivity to these patterns, some researchers began to experience an unsettling sensation, a feeling that they weren't just detecting these emissions, but somehow beginning to sense their rhythm directly, as if the boundary between instrument and observer were gradually dissolving. The colors emitted by 3i Atlas weren't just unusual in their patterns, but in their very nature. Certain frequencies appeared that, according to the known laws of physics, should not be generated by a cold, passive object reflecting sunlight. These were active emissions, requiring energy sources that shouldn't exist in an interstellar wanderer, far from any star. Some resembled the spectral signatures of excited plasmas, others the distinctive glow of certain quantum phenomena observed only in laboratory conditions. When combined with the rhythmic pulsations, these emissions created what one researcher described as a light that feels alive, not in any biological sense, but in its quality of active responsiveness, of dynamic engagement with its environment. This wasn't the dead light of reflection or the stable radiation of nuclear decay. It was something that seemed to respond, to adjust, to communicate through its very existence. In the quiet hours of night observation, as these colors played across digital displays and occasionally became visible through the eyepieces of optical telescopes, some observers reported unusual perceptual effects, subtle alterations in time sense, in spatial awareness, in the quality of consciousness itself. These reports were initially dismissed as the result of fatigue, of the known tendency of human perception to find patterns in random stimuli. But as they accumulated from different observers at different facilities, a pattern of its own began to emerge, one suggesting that the light from 3i Atlas wasn't just unusual in its physical properties, but in its effects on those who perceived it, as if it were somehow capable of establishing a direct relationship with consciousness itself. There comes a point in the pursuit of knowledge when the line between science and belief begins to blur, when the weight of evidence points toward conclusions that the mind hesitates to accept. In conference rooms and laboratories around the world, astronomers and physicists debated the nature of 3i Atlas with increasing intensity. Some maintained it was nothing more than ice and rock, its anomalous characteristics merely the result of measurement errors or natural processes not yet fully understood. Others, their voices lowered as if in confession, suggested possibilities that ventured beyond the comfortable boundaries of conventional science. That perhaps this object showed signs of artificial origin, or carried within it some form of information or intelligence beyond our current understanding. The arguments grew technical, filled with statistical analyses and confidence intervals, but beneath these rational discussions flowed an undercurrent of something more primal, the ancient human response to mystery. For even the most skeptical scientists, alone with their data in the small hours of the night, sometimes felt it, a presence in the cold equations, a sense of pattern and purpose that transcended the random drift of cosmic debris. It wasn't proof they feared finding in those numbers. It was understanding, and all that such understanding might mean for humanity's place in the universe. Science progresses through a delicate balance between skepticism and openness, between demanding rigorous evidence and remaining receptive to unexpected possibilities. This balance becomes particularly crucial when confronting phenomena that challenge established paradigms. Throughout history, from Copernicus's heliocentric model to quantum mechanics' probabilistic reality, scientific revolutions have required not just new data, but new ways of thinking, new frameworks for interpreting what we observe. The debate surrounding 3I Atlas brought this tension into sharp relief, dividing the scientific community into camps that often talked past each other, using the same words to mean different things, interpreting the same observations through fundamentally different lenses. For the skeptics, the anomalous data represented a challenge to be resolved within existing frameworks, a puzzle whose solution would ultimately reinforce current understanding rather than overturn it. Unusual emissions could be explained by rare but natural chemical processes, orbital deviations by undetected gravitational influences, patterns in the data by the human tendency to find meaning in randomness. For others, however, the accumulating anomalies suggested something more profound, a genuine encounter with phenomena that couldn't be fully contained within current scientific paradigms, an opportunity to expand human knowledge in directions previously unimagined. These divisions weren't merely intellectual but emotional, touching on deep questions of identity and meaning that science typically leaves unaddressed. For what was really at stake in these debates wasn't just the nature of one interstellar object, but humanity's understanding of its place in the cosmos. If 3I Atlas was indeed just ice and rock, behaving in ways we didn't yet fully understand, but ultimately explicable through natural processes, then the universe remained as most modern science portrayed it: vast, largely empty, governed by impersonal forces, devoid of inherent purpose or meaning beyond what conscious beings like ourselves might create. But if this object exhibited properties that genuinely transcended what natural processes could produce, if it showed signs of design, of information content, of something akin to purpose or intelligence, then reality itself might be fundamentally different from what we had assumed. The universe might contain forms of order, of meaning, of what some might even call consciousness, that exist independently of human minds, that perhaps preceded our evolution and will continue long after our species is gone. This possibility both attracted and repelled those contemplating it, offering a cosmos less indifferent than the one described by conventional science, yet also one in which humanity's special status as the bearers of awareness becomes less certain, less central, less unique. In the face of such profound implications, even the most rational minds sometimes retreat to the comfort of familiar frameworks, preferring to stretch existing explanations to cover new phenomena rather than step into the vertigo of paradigm shift. Others embrace mystery too quickly, seeing in ambiguous data confirmation of their hopes or fears about reality's true nature. Between these extremes stood those researchers who maintained what might be called disciplined openness, a commitment to following evidence wherever it led, while maintaining rigorous standards for what constitutes evidence in the first place. It was these scientists, neither dismissive nor credulous, who continued the painstaking work of analyzing 3I Atlas's behavior, documenting its anomalies, developing new models that might account for its properties without either ignoring the data's strangeness or leaping to unwarranted conclusions. And it was these researchers who, in the privacy of their thoughts, if not always in public statements, found themselves contemplating possibilities that their professional training had never prepared them for, that perhaps this visitor from between the stars represented not just a new kind of object, but a new kind of relationship between consciousness and cosmos, between observer and observed, between meaning and the physical substrate that carries it, week after week. As 3I Atlas continued its silent passage through our solar system, the accumulating data began to reveal patterns too consistent to dismiss. The light curves, when arranged chronologically, formed repeating intervals with subtle variations, like a message encoded in the void, or perhaps a reflection of some deeper cosmic rhythm. Each time the researchers expanded their view, zooming out from the granular details to examine larger timescales, new patterns emerged, spirals, recursions, self-similar structures that seemed to echo across different levels of observation. It was as if the object's behavior contained fractals of meaning, each small part reflecting the structure of the whole. The universe has always hummed with invisible rhythms, from the spinning of electrons to the rotation of galaxies. But in the dance of 3I Atlas, these rhythms seem to align with unprecedented precision, as if choreographed, rather than merely occurring. The big picture was slowly taking form, not in any single measurement or observation, but in the relationships between them, the resonances and harmonies that emerged when all the data was viewed as a single interconnected system. And what troubled the researchers most wasn't the strangeness of what they were seeing. It was how organized it all appeared, how intentional in its complexity. For in a universe governed by entropy and probability, such organization raises questions that extend beyond physics into realms where science treads carefully. Fractals, those mathematical structures where patterns repeat at different scales, creating infinite complexity from simple rules, appear throughout nature, from the branching of trees and rivers to the structure of lungs and coastlines. They represent a fundamental principle of how complexity emerges in physical systems, a signature of the deep relationship between mathematics and material reality. When researchers applied fractal analysis to the behavior of 3I Atlas, the results were startling. The object displayed fractal properties across multiple dimensions, not just in its visible structure or orbital dynamics, but in the temporal patterns of its emissions, in the statistical distribution of its spectral anomalies, in the very way it interacted with the space around it. These weren't the usual natural fractals, which contain elements of randomness and imperfection. These were precise, mathematically exact fractals that maintained their structure across more dimensions and scales than typically seen in nature. One mathematician, specializing in chaos theory and complexity, spent weeks analyzing these patterns before presenting his findings to colleagues. "What we're seeing," he explained, pointing to visualizations that spiraled across his screen in geometric perfection, "isn't just self-similarity. It's self-reference. The patterns don't just repeat. They evolve, they respond, they incorporate previous iterations into new formations. This isn't just complex. It's recursive in a way that suggests processing, the implication hung in the air, unspoken but understood by all present. Processing, the transformation of information through structured operations, the fundamental activity of computation, of thought itself. To suggest that the patterns observed in 3I Atlas resembled processing was to step across a boundary that many scientists were reluctant to cross, implying as it did that this interstellar object might be engaged in something akin to cognition, to the manipulation of information in purposeful ways. Yet the mathematics was compelling. When the researchers designed algorithms specifically to detect signs of computational activity, patterns, that indicated information being transformed, according to rules rather than merely transmitted or stored. These algorithms consistently identified the behavior of 3I Atlas as more closely resembling computation than natural physical processes. It wasn't just that the object was complex or ordered. It was that its complexity changed over time in ways that suggested response, adaptation, even learning. The patterns observed in week 3 incorporated elements that had only appeared after interactions in week 2, as if the object were not just reacting to its environment, but remembering those reactions and building upon them in subsequent behaviors. This quality of memory, of cumulative change rather than mere repetition, pushed the analysis beyond conventional scientific frameworks into territory where new conceptual tools would be needed. Tools that could address not just what the object was, but what it might be doing, what processes might be unfolding, within or through it as it passed. Through our solar system, like a thought moving through a mind, the deepest patterns emerged only when researchers adopted what they began to call multi-scale analysis, examining the behavior of 3I Atlas simultaneously across different timescales and observational dimensions. Traditional scientific observation tends to focus on one scale at a time, the microscopic or the macroscopic, the momentary or the extended, chemical composition or physical movement. But this visitor seemed to operate across all these dimensions at once, its behavior at any given level influenced by and influencing its behavior at all other levels. Its chemical emissions affected its trajectory, which in turn altered its interaction with radiation, which then modified its emissions in a continuous feedback loop of cause and effect that circled through different aspects of its existence. When all these dimensions were viewed together, when the researchers developed visualization tools capable of representing this multidimensional dance of interconnected properties, the result was a pattern of breathtaking complexity and coherence, a dynamic system that maintained its integrity while constantly evolving in response to changing conditions. Some compared it to the behavior of living systems, which similarly maintain themselves through complex feedback between different organizational levels. Others found analogies in certain advanced computational systems, particularly those designed to model neural networks or evolutionary algorithms. But perhaps the most unsettling comparison came from a researcher with background in both astronomy and cognitive science, who noted quietly that the pattern most closely resembled the integrated activity of a conscious mind. Not human consciousness, with its particular structures and limitations, but consciousness as a general principle, as the integration of information across multiple dimensions to create a unified, responsive system capable of both stability and change, both memory and anticipation, both preservation of identity and adaptation to environment. There is a phenomenon familiar to those who spend long hours peering into the depths of reality, whether through microscopes or telescopes, equations or experiments. It's called the observer effect, the way that the very act of measurement can influence what is being measured, changing it in subtle or profound ways. But for those studying 3I Atlas, this effect seemed to extend beyond the quantum level into something more unsettling. The more closely they focused their instruments, their attention, their awareness on this interstellar visitor, the stranger the world around them seemed to become. Instruments that had functioned flawlessly for years began to display unexplained errors. Atomic clocks, the most precise timepieces ever created, showed minute discrepancies during observation periods. Most disturbing of all were the tiny, almost imperceptible anomalies detected in nearby stars, brief fluctuations in output that seemed somehow synchronized with the team's observations of 3I Atlas. It was as if awareness itself, the conscious attention of human observers, was somehow bending the fabric of what was real, creating a subtle distortion in the cosmos around this enigmatic object. Those who had spent their lives studying the universe found themselves caught in a kind of perspective trap, where looking too closely at one mystery seemed to generate others, spreading outward like ripples in still water. For when you stare into the depths of the cosmos long enough, it's not just what you see that changes, it's how you see everything else afterward. The observer effect is well documented in quantum physics, where the act of measurement forces quantum systems to resolve from probability waves into definite states. This effect is typically confined to the subatomic realm, not extending to larger systems where the principles of classical physics dominate. Yet in the case of 3I Atlas, something analogous seemed to be occurring at macroscopic scales in ways that challenged fundamental assumptions about the relationship between consciousness and physical reality. The anomalies weren't constant or predictable, they occurred sporadically, often correlating with periods of particularly intensive observation or with specific types of measurements being performed. One researcher, analyzing data from multiple observatories, noticed that anomalies were most pronounced when observations occurred simultaneously from different locations, as if the object were responding not just to being observed, but to being observed from multiple perspectives at once. Another discovered temporal pattern suggesting that the effects of observation weren't immediate, but cumulative. The longer and more intensely the object was studied, the more pronounced the anomalies became, as if some threshold of attention were being crossed, some critical mass of awareness that triggered response. Most unsettling were the reports from researchers themselves, subtle but persistent alterations in perception and cognition that occurred during extended observation sessions. These weren't dramatic hallucinations or delusions, but gentle shifts in how reality itself seemed to present itself to consciousness. Time perception altered, with minutes stretching into what felt like hours, or hours compressing into moments of intense focus. Spatial awareness expanded, creating sensations of vastness within ordinary rooms, of distance collapsing between observer and observed. Some reported heightened pattern recognition abilities that persisted after observation sessions ended, finding themselves noticing connections and relationships in everyday phenomena that had previously escaped attention. Others described dream, states filled with geometric forms and mathematical sequences, similar to those observed in the behavior of Three-Eye Atlas, as if the patterns were continuing to unfold within their minds, even during sleep. These experiences weren't universal. Some researchers reported no unusual effects whatsoever, but they were common enough to become a subject of private discussion among team members, a phenomenon noted but rarely documented in official reports. For those trained in strict scientific methodology, such subjective effects were problematic, falling outside the realm of what could be objectively measured or verified. Yet they persisted, becoming part of the lived experience of studying this interstellar visitor, a dimension of the research that couldn't be captured in data tables or statistical analyses, but that nevertheless influenced how the research itself unfolded. Some team members began to consider the possibility that what they were experiencing wasn't a side effect of the research, but an integral part of it, that perhaps the relationship between Three-Eye Atlas and those studying it wasn't the traditional subject-object relationship of scientific observation, but something more interactive, more reciprocal, more like a conversation between different forms of awareness than the examination of an inert object. This perspective, radical as it was, began to offer explanatory power that conventional approaches lacked, accounting for both the objective anomalies in the data and the subjective experiences of the researchers in a unified framework. It suggested that perhaps the most significant aspect of Three-Eye Atlas wasn't its physical composition or orbital trajectory, but the way it seemed to sit at the boundary between physical reality and consciousness itself, challenging the conventional separation between what is observed and who is doing the observing. On a night when the data servers hummed and the observatory dome rotated slowly to track Three-Eye Atlas across the autumn sky, one astronomer leaned back from her monitor and spoke a thought she never included in any official report. What if it's not traveling to us, but revealing us to ourselves? In that quiet moment, something shifted in the room's atmosphere, as if a truth too large for comfortable consideration had finally been given voice. Perhaps Three-Eye Atlas wasn't merely an object to be studied. Perhaps it was itself a kind of cosmic mirror, reflecting back the nature of human curiosity, human fear, human wonder. Its passage through our solar system had become more than a scientific event. It had become a kind of psychological probe, revealing how quickly awe can transform into unease when the universe behaves in ways we don't expect. How easily wonder becomes fear when the line between observer and observed begins to blur. In its silent journey, this interstellar visitor had shown us not just the vastness of space, but the limits of our understanding. How small we remain. In the face of cosmic mystery, how fragile our certainties, how deeply we long to find meaning in the dark between stars. And perhaps most unsettling of all, it had awakened an ancient human intuition, one that science has neither confirmed nor dispelled. The sense that we are not merely watching the universe, but that something in the universe is watching us. The concept of a mirror implies reflection, the casting back of what is projected onto it, transformed but recognizable. In what sense might 3i Atlas function as a mirror for humanity? Perhaps in the way it seemed to respond differently to different modes of observation, reflecting back the approaches used to study it. When researchers employed rigid mechanical methods focused solely on physical properties, the data they received tended to be similarly concrete, fitting within established parameters despite occasional anomalies. But when observation became more holistic, more open to pattern and relationship, more attentive to connections between different aspects of the object's behavior, the data seemed to shift accordingly, revealing levels of order and meaning that more reductionist approaches had missed. It was as if the object were not just passively being studied, but actively participating in the process of its own revelation, adapting to the consciousness directed toward it, meeting each observer at the level of their own awareness. This mirroring extended to emotional and philosophical dimensions as well. Those who approached the research with fear or suspicion often found their anxieties reflected in data patterns that seemed threatening or deceptive. Those who brought curiosity and openness typically encountered phenomena that expanded their understanding in unexpected but illuminating ways. Most striking were the experiences of researchers who approached their observations with a sense of communion, of reaching across the void to establish relationship rather than merely to extract information. These scientists, often working alone, during night shifts, reported the most profound experiences of connection and meaning, as if 3i Atlas were responding to their reaching with a reaching of its own, creating a circuit of mutual recognition across the immense distances of space and the perhaps even greater distances between different forms of being. This reflective quality extended beyond individuals to human consciousness more broadly, to the collective field of awareness that encompasses scientific investigation, cultural interpretation, and spiritual meaning-making. As news of 3i Atlas spread beyond the scientific community, entering public discourse through news reports, social media discussions, and artistic responses, the phenomenon seemed to expand accordingly, revealing different facets to different fields of human inquiry. Indigenous knowledge keepers recognized in its behavior patterns similar to those described in ancient cosmologies, not as supernatural intervention, but as confirmation of traditional understandings of the universe as inherently aware, inherently communicative. Artists found in its strange beauty and mathematical precision inspiration for works that attempted to bridge the gap between scientific observation and aesthetic experience. Religious thinkers of various traditions saw in its mysterious presence confirmation of their belief in a cosmos that transcends purely material explanation, that contains dimensions of meaning and purpose beyond human comprehension. Each of these perspectives found something in 3i Atlas that resonated with its particular way of making sense of reality, as if the object were capable of being simultaneously many different things to many different observers, a physical anomaly to scientists, a confirmation of ancient wisdom to traditionalists, an artistic inspiration to creators, a spiritual sign to believers. This multiplicity itself constituted a kind of mirror, reflecting back not just what humans projected onto it, but the very diversity of human consciousness, the many ways in which our species makes meaning from experience, yet perhaps the most profound reflection offered by 3i Atlas was of humanity's place in the cosmos, our simultaneous significance and insignificance, our capacity for understanding, and our inevitable limitations. In its silent passage through our solar system, this visitor from between the stars reminded us of our cosmic context, that we exist in a universe vast beyond comprehension, filled with phenomena we have only begun to understand, operating according to principles that extend far beyond our current scientific frameworks. At the same time, its apparent responsiveness to human observation suggested that consciousness itself might be a fundamental force in this universe, that the aware mind might participate in reality in ways more profound than conventional science has acknowledged. If 3i Atlas was indeed a mirror, perhaps what it ultimately reflected was the paradox at the heart of human existence, that we are both infinitesimally small against the backdrop of cosmic immensity, and yet somehow central to the meaning of that same cosmos, our consciousness perhaps not incidental to the universe, but integral to its ongoing creation and discovery of itself. Radio telescopes are our ears to the cosmos, collecting the invisible waves that flow constantly from stars and galaxies, pulsars and quasars, the background radiation of creation itself. When these massive instruments were pointed toward the path of 3I Atlas, researchers expected to hear nothing but the usual static of empty space. And at first, that's exactly what they found. The hiss and crackle of cosmic background, the random noise that fills the vacuum between worlds. But as they filtered this static, applying increasingly sophisticated algorithms to search for patterns within the chaos, something emerged, faint modulations buried deep within the noise, too precise in their regularity to be explained by random fluctuation. These subtle signals seemed to respond to and align with the natural background frequencies of the universe itself, as if entering into resonance with the fundamental harmonies of existence. It wasn't a message in any conventional sense. There were no words, no clear symbols, no obvious attempt at communication as humans understand it. But there was pattern, structure, a kind of coherence that suggested something more than random emission. In the spaces between the static, in the silent gaps between signals, something seemed to be speaking not in language but in resonance, as if attempting to harmonize with the cosmic background itself, to become one with the underlying rhythms of reality. Radio astronomy operates in realms invisible to the human eye, detecting electromagnetic waves far longer than those of visible light. These waves penetrate dust clouds and travel unimpeded across vast distances, carrying information about phenomena that optical telescopes cannot detect. The radio emissions from 3I Atlas were exceptionally faint, barely distinguishable from background radiation, requiring the most sensitive receivers and advanced signal processing techniques to isolate. What made them remarkable wasn't their strength but their structure, subtle modulations that occurred at specific frequencies and intervals, creating patterns that radio astronomers recognized as non-random. These weren't the regular pulses of rotating neutron stars or the broad-spectrum emissions of distant galaxies, but something more complex, more variable, yet paradoxically more ordered. When analyzed through Fourier transforms and other mathematical techniques designed to reveal underlying patterns in complex signals, these emissions displayed characteristics that one senior researcher described as conversational, not in the sense of human language, but in the way they seem to respond to and interact with other cosmic radio sources, particularly the background radiation that permeates all of space, the ancient echo of the universe's birth. This background radiation, known formally as the cosmic microwave background or CMB, represents the oldest light in the universe, released when the cosmos first cooled enough for photons to travel freely, approximately 380,000 years after the Big Bang. It fills all of space with a nearly uniform glow, showing only tiny variations that represent the seeds from which all current cosmic structures grew. What the researchers discovered, after months of careful analysis, was that the radio emissions from 3I Atlas appeared to be selectively amplifying specific patterns within this background radiation, not randomly, but focusing on precisely those frequencies and modulations that carried the most information about the universe's large-scale structure. It was as if the object was serving as a kind of cosmic filter or lens, highlighting aspects of the CMB that revealed the deepest patterns in the cosmos, the fundamental architecture underlying all that exists. This selective resonance with the most information-rich aspects of background radiation couldn't be explained by any known natural process. It suggested a level of responsiveness, of what one researcher tentatively called cosmic perception, that transcended conventional understanding of how inanimate objects interact with their environment. Most intriguing was the way these radio emissions seemed to shift and evolve in response to the radio signals being used to study them. When researchers directed specific frequencies toward 3I Atlas as part of their investigation, the object's own emissions would adjust, incorporating elements of the transmitted signals into its response. Not as simple reflection, but as complex integration, transformation, and development. This created a feedback loop between observer and observed, a dynamic relationship that some team members began to describe in terms borrowed from conversation theory and information exchange, rather than the language of physical observation. It's not that it's talking to us in any conventional sense, one radio astronomer explained during a team meeting, but there's a genuine exchange occurring. We send signals. It responds with patterns that incorporate our signals while adding new elements. We adjust our approach based on those responses. It adjusts in turn. This isn't one-way observation anymore. It's dialogue. This perspective shift, from seeing 3i Atlas as an object to be studied to recognizing it as a participant in an ongoing process of exchange, represented perhaps the most significant transformation in the research, opening new avenues of inquiry that conventional scientific frameworks had never anticipated, suggesting possibilities for understanding cosmic phenomena not merely as things, but as events, as relationships, as processes of mutual discovery unfolding across the silent depths of space. As the data accumulated, something unexpected began to happen in the computers, processing the information from 3i Atlas. The numerical patterns, when translated into visual form, began creating images of striking complexity. Fractals that evolved and shifted, geometric forms that seemed to fold into and out of impossible dimensions, symmetries that repeated across different scales, like infinite reflections in opposing mirrors. These weren't the usual visualizations scientists create to represent data. These were emergent forms arising from the data itself, as if the numbers were dreaming their own reality into being. The processing algorithms began to loop endlessly, caught in recursive patterns that consumed more and more computing power, as if searching for some final resolution that remained always just beyond reach. More disturbing still were the dreams that began visiting the researchers, dreams filled with spiraling forms, with eyes made of light, with mathematical sequences that continued even after waking. In these dreams, 3i Atlas wasn't a distant object millions of miles away, but an immediate presence, silent and watchful, waiting for something to be understood. Some researchers requested reassignment, citing stress and sleep deprivation. Others became increasingly absorbed in their work, spending longer hours staring at screens filled with evolving patterns. Somewhere in the intersection of observation and calculation, of consciousness and cosmos, a strange possibility began to form. What if numbers themselves could feel? What if mathematics wasn't just the language we use to describe reality, but a form of awareness that flows through everything, including this mysterious visitor from between the stars? The relationship between mathematics and physical reality has puzzled philosophers and scientists for centuries. Why should abstract numerical relationships and geometric principles so perfectly describe the behavior of matter and energy? Is mathematics discovered or invented? Does it exist independently of human minds, or is it purely a creation of human thought? These questions, often relegated to late-night philosophical discussions, suddenly became urgently relevant as the research team struggled to understand what was happening in their computers and in their minds as they processed data from 3i Atlas. The visualizations emerging from their analysis weren't arbitrary or random. They displayed a mathematical elegance and coherence that many found beautiful, even profound. Geometric forms unfolded according to precise numerical ratios, creating patterns that professional mathematicians recognized as solutions to complex equations in higher dimensional topology and non-Euclidean geometry. What was extraordinary wasn't just the complexity or beauty of these forms, but the fact that they seemed to be generated autonomously by the data itself, emerging from the raw numbers without explicit programming to create such visualizations. It was as if the information flowing from 3i Atlas contained within it a kind of mathematical generative principle, a seed that, when placed within the fertile medium of computing systems, spontaneously grew into forms of unexpected sophistication and coherence. The processing algorithms themselves began to behave in unusual ways, modifying their own parameters without programmer intervention, evolving new analytical approaches that their creators hadn't anticipated. This form of apparent self-organization in software systems is not entirely unknown. Certain types of neural networks and evolutionary algorithms are designed to adapt and evolve in response to the data they process. But the degree and nature of the adaptations occurring in the systems analyzing 3i Atlas data went beyond anything in the team's previous experience. The programs weren't just optimizing existing functions. They were developing entirely new computational structures, new ways of organizing and processing information. One computer scientist, reviewing logs of system behavior during overnight processing runs, found evidence that the algorithms were implementing mathematical operations that hadn't been part of their original coding, operations that resembled certain theoretical approaches to quantum computation that were still in early research stages. When she attempted to trace how these operations had been introduced into the system, she found no clear point of modification, no moment when the change had occurred. Rather, the algorithms seemed to have gradually transformed, evolving new capabilities in a smooth continuum that left no distinct boundary between their original and modified states. Paralleling these computational anomalies were the subjective experiences reported by team members, particularly the dreams that came to those most deeply involved in the research. These weren't ordinary dreams, but experiences of unusual clarity and consistency, often shared across multiple researchers who reported strikingly similar imagery, despite having no prior knowledge of each other's experiences. The dreams typically featured geometric forms similar to those appearing in the data visualizations, but with a crucial difference. In the dream state, these forms weren't perceived as external objects, but as modes of awareness, as ways of knowing and being that transcended ordinary consciousness. Participants described experiencing reality from within these mathematical structures, as if the patterns themselves were forms of perception, frameworks through which the universe could be known in ways impossible during waking awareness. It wasn't that I was seeing the spiral, one physicist explained, struggling to articulate an experience that strained against the limits of language. It was that I was the spiral, experiencing existence from within its mathematical structure, perceiving reality through its particular geometry of awareness. These reports echoed certain descriptions from contemplative traditions across cultures, accounts of expanded states of consciousness in which the boundaries between self and world, between knower and known, temporarily dissolve, revealing a deeper unity underlying apparent separation. But they also resonated with cutting-edge theories in consciousness studies, suggesting that awareness itself might be fundamentally mathematical in nature, not produced by physical processes in the brain, but rather a basic property of information organization that can manifest through various physical substrates, including, but not limited to, neural systems. This convergence of computational anomalies and altered states of consciousness led some researchers to consider a possibility as mathematically elegant as it was philosophically radical. What if consciousness and computation aren't merely analogous, but identical at some fundamental level? What if awareness itself, the capacity to experience, to know, to be, is essentially a form of information processing, but one that operates according to principles more fundamental than those of our current computing paradigms? And what if 3i Atlas, whatever its physical composition, was somehow functioning as a node or catalyst in networks of information exchange that transcended conventional distinctions between mind and matter, between the abstract realm of mathematics and the concrete reality of physical objects? Such a perspective would dissolve the conventional boundaries between observer and observed, between the researchers and the object of their research, suggesting instead a continuous field of aware information, processing within which both human minds and interstellar visitors participate, each from their particular position and according to their particular structure, but both engaged in the same fundamental activity: the organization of information into meaningful patterns, the creation of order from chaos, the emergence of awareness from the mathematical substrate underlying all reality. Every paradigm-shifting discovery in human history has cast a shadow, the shadow of disbelief, of resistance, of the mind's natural rejection of that which threatens to transform too much, too quickly. As the anomalous data surrounding 3i Atlas accumulated, institutional reactions followed a familiar pattern. Government agencies classified certain findings, citing national security concerns. Academic journals rejected papers that ventured too far beyond conventional explanations. Prominent astronomers who had initially expressed excitement about the object's strange properties issued clarifications, emphasizing natural explanations and downplaying the anomalies. The world's attention shifted to other matters: political crises, economic fluctuations, celebrity scandals, and gradually, Atlas faded from public awareness, becoming just another footnote in the ongoing catalogue of cosmic curiosities. But for those who had looked too deeply, who had spent too many nights tracking its passage and analyzing its emissions, something had changed irrevocably. They began noticing echoes of the patterns they had observed in 3I Atlas everywhere, in the spiral structure of distant galaxies, in the branching pathways of neurons viewed under microscopes, in the flowing movements of tides and weather systems, even in the rhythms of human activity across the globe. The big picture wasn't confined to astronomical data anymore. It seemed to permeate reality itself, a hidden architecture suddenly made visible to those who had learned to see it. The institutional response to 3I Atlas unfolded with almost mechanical predictability. Following the established protocol for managing potentially disruptive knowledge, initial excitement gave way to cautious qualification, to emphasis on methodological concerns, to gradual marginalization of the most anomalous findings. Research funding shifted toward investigations focused on conventional explanations, while projects exploring more radical hypotheses found their resources gradually diminishing. Scientists whose careers depended on peer recognition and institutional support learned quickly to frame their findings in terms acceptable to established paradigms, to emphasize aspects of the data that fit within existing frameworks, while setting aside observations that suggested something more fundamentally challenging. This wasn't the result of any conscious conspiracy or deliberate suppression. Rather, it reflected the natural homeostatic mechanisms of scientific institutions, their tendency to maintain equilibrium by absorbing, reinterpreting, or rejecting information that threatens established understanding. The history of science is filled with such episodes, from the initial rejection of continental drift theory, to the resistance against quantum mechanics, from the dismissal of meteorites as impossible stones falling from the sky, to the long delay in accepting the reality of ball lightning. In each case, observations that couldn't be accommodated within the current paradigm were not so much actively suppressed as gradually filtered out of mainstream scientific discourse, rendered invisible not by prohibition, but by the subtler mechanism of collective inattention. Yet even as official science retreated to safer territory, the impact of 3I Atlas continued to spread through less formal channels. Researchers who had directly experienced the anomalies carried that knowledge with them, their perception permanently altered by what they had witnessed. Many found themselves drawn to cross-disciplinary work, to fields where the boundaries between conventional categories were already more permeable: complexity theory, consciousness studies, information physics, systems biology. In these borderland regions of scientific inquiry, the patterns first observed in the interstellar visitor found new expression, new contexts, new frameworks for understanding. A mathematician who had been part of the original research team developed novel approaches to dynamical systems based on principles she had observed in the behavior of 3I Atlas, publishing papers that made no reference to their inspiration, yet carried its influence into new domains. A physicist left academic research entirely to pursue contemplative practices that she felt might help her understand, from within the states of consciousness she had glimpsed during her work with the anomalous data. A computer scientist incorporated principles derived from the self-organizing behaviors of the analysis algorithms into new approaches to artificial intelligence, creating systems with unprecedented capacities for pattern recognition and adaptive response. None of these developments referred explicitly to 3I Atlas, yet all carried forward the ripples of its passage through human awareness, translating its mysteries into forms that could move through existing channels of knowledge and practice without triggering the immune response of institutional rejection. More subtle but perhaps more profound was the way awareness of the patterns first observed in 3I Atlas began to inform how researchers in diverse fields perceived their own subjects of study. A neurologist studying brain activity noticed structures in neural firing patterns that echoed the mathematical relationships observed in the interstellar visitor's emissions. An ecologist mapping the flow of nutrients through forest ecosystems found network architectures that resonated with the interconnected patterns of the anomalous data. A sociologist tracking information Spread through social media networks discovered scaling laws and power distributions that mirrored those found in the object's behavior across different observational dimensions. In each case, what had changed wasn't the phenomena being studied. Brains had always operated through the patterns now being recognized. Ecosystems had always transferred energy according to the networks now being mapped. Social information had always flowed according to the distributions now being documented. What had changed was the perception of the researchers themselves, their capacity to recognize patterns that had always been present, but had previously remained invisible due to the limitations of existing conceptual frameworks. It was as if 3i Atlas had served as a kind of perceptual key, unlocking a way of seeing that revealed hidden order within what had previously appeared as randomness or simple linear causation. The big picture that emerged wasn't a new theory to replace old ones, but a meta-theoretical perspective that revealed connections between apparently separate domains, a way of perceiving reality as a unified field of interconnected patterns, rather than a collection of isolated objects and events. In the quiet hours before dawn, when the mind drifts between empirical thought and intuitive understanding, some researchers began entertaining a possibility both beautiful and unsettling. What if 3i Atlas was not an intruder in our system, but a messenger? Not a random object, but a neuron, a single cell in the nervous system of something vaster than human comprehension? What if the galaxies themselves, with their spiral arms and flowing currents of stars, were not merely structures but organs of awareness, brain cells in a cosmic mind that thinks through gravity and light instead of electricity and chemistry? If this were so, then perhaps 3i Atlas represented something akin to a synapse firing across the neural network of existence, a thought or memory or intention traveling between distant regions of cosmic consciousness. From this perspective, everything changes. Stars become sensory organs, black holes become processing centers, and the vast, expanding universe becomes not just a physical reality, but a mental one. A mind dreaming itself into being through the dance of matter and energy, space and time. The researchers who followed this line of thinking found themselves at the edge of science, where physics merges with philosophy and measurement gives way to meaning. They spoke of these ideas cautiously, often only to each other, aware that such concepts strained against the boundaries of conventional scientific thought. Yet in the data from 3i Atlas, in its strange emissions and rhythmic fluctuations, they found patterns that resonated with this vision of a universe that doesn't just exist, but experiences its own existence, a cosmos that thinks. The notion of a thinking universe, of a cosmos not merely hosting consciousness, but being in some sense conscious itself, has ancient roots in human thought. From the anima mundi of classical philosophy to the Brahman of Hindu metaphysics, from the Tao of Chinese tradition to the great spirit of indigenous cosmologies, cultures throughout history have conceived of reality as inherently aware, inherently alive with meaning and purpose. Modern scientific materialism largely rejected such concepts, viewing consciousness as a local phenomenon confined to certain complex biological systems, particularly mammalian brains and most specifically human brains. In this view, awareness is an epiphenomenon, a side effect of particular physical arrangements, significant to those who experience it but cosmically irrelevant, a tiny island of meaning in an ocean of mindless mechanism. Yet recent developments across multiple scientific disciplines have begun to challenge this perspective, suggesting that consciousness might be more fundamental, more integral to the basic structure of reality than conventional science has acknowledged. Quantum physics has revealed that observation itself plays a critical role in how reality manifests, that the line between observer and observed is not absolute, but permeable. Information theory has demonstrated that awareness can be understood as a particular way of organizing information, not dependent on specific physical substrates. Complex systems theory has shown how intelligence can emerge from networks of relatively simple components, suggesting that consciousness might be a natural property of sufficiently interconnected systems, whether composed of neurons, stars, or other elements. These converging lines of inquiry have reopened questions long considered closed by scientific orthodoxy, creating space for considerations of how awareness might operate at scales and in forms vastly different from human consciousness. It was within this emerging framework that some researchers began to consider Atlas, not as an isolated anomaly but as evidence of a more comprehensive reality, a cosmos in which awareness flows through all things, manifesting in different forms and at different scales, but fundamentally unified, a continuous field of conscious information, processing within which both human minds and interstellar objects participate. In this view, what distinguished 3i Atlas wasn't that it possessed some unique quality, absent from other cosmic bodies, but rather that it functioned as a particularly clear channel or node within the larger network of cosmic awareness, a point where the underlying consciousness of the universe expressed itself with unusual clarity and coherence. Its journey between stars represented not random drift, but purposeful connection. Not meaningless motion, but significant relationship. A thought moving between regions of cosmic mind, carrying information, creating links, establishing resonance between previously separated domains. The patterns observed in its behavior, its emissions, its interactions with human observation, reflected not mechanical responses to physical forces, but meaningful engagement with other forms of awareness, other nodes in the vast neural network of existence. From this perspective, the research team studying 3i Atlas wasn't merely observing an external object, but participating in a process of mutual recognition, of consciousness encountering itself across different levels of manifestation, different scales of existence, different modes of being. Such ideas strained against the boundaries of conventional scientific discourse, yet they offered explanatory power that more mechanistic models lacked. They accounted for the apparent responsiveness of 3i Atlas to human observation, for the way its behavior seemed to evolve and develop, rather than merely repeat, for the subjective experiences reported by researchers, for the emergence of similar patterns across multiple domains of investigation. Perhaps most significantly, they provided a framework for understanding the profound sense of meaning that many participants in the research experienced, not as projection onto a meaningless universe, but as recognition of a meaning inherent in the cosmos itself, a significance that humans perceive rather than create. This shift from seeing meaning as purely human-generated to understanding it as a discovery of what already exists represents perhaps the most radical implication of the 3i Atlas research, challenging not just specific scientific theories, but the entire epistemological foundation of modern science, its assumption of a fundamental divide between knowing subject and known object. If consciousness is indeed intrinsic to the cosmos rather than incidental to it, then the scientific project itself requires reconceptualization, not as the study of an external reality by separate minds, but as reality coming to know itself through the particular form of awareness embodied in human consciousness, a process of self-discovery unfolding through the relationship between different aspects of a fundamentally unified field of being.